the last one, we did a bit of revision, okay? Now we're going to look at some of the trig identities. And I'm going to repeat myself. You know, all I'm trying to do some of the more difficult ones in here just to show you I can't cover in the sessions every single eventuality. I'm going to obviously add more and more and more videos into this as we move on, as time moves on, but we can't cover everything straight off, okay? So it is critical to develop some neural pathways here that you have to struggle a little bit with these things, okay? If you stay with the basic recipe that we've put forward, it acts as a fairly good guideline to look for factorization, okay? So that is why with all my students, I push heavily factorizing because it's one of the basics of the lot. So if you're not hundreds or totally au fait with factorizing, do a little bit more of it, okay? It's well worth the input, I promise you. Your returns from this bit of work is huge. It's in trig, it's in algebra, it's in graphs, it's everywhere. So the process of factorizing is critical. There we go. I've done my sermon for the day. Well, whatever. But seriously, in all honesty though, it really is critical for us to understand the factorization concept, right? And once you've done a few, you'll see, oh yes, I've seen that before. Yes, I've seen that before. The only new bit here is the conjugate, isn't it? And the conjugate is the same as rationalizing the denominator in surds. Remember when you had a root underneath? Okay, a surd underneath. Let me not call them roots, okay? Right, prove that. Okay, let's do an example, shall we? Example. Prove that tan theta over sine squared theta, tan theta divided by sine squared theta minus tan theta is equal to 1 over tan theta. Terrible. Before the editor tells me to redo it, I will redo it. Tan theta. Essentially, this is a proof. But look at what we've done, right? We've taken something that's long, complicated, and involved, and we have simplified. Okay? So essentially, identities are the same as trig simplify. Okay? As algebra simplify. Okay, so what did I say? We said, right, start with the left-hand side, write it down, tan theta over sine squared theta minus tan theta. And now we're going to, what did we do? The recipe said, change tan to sine over cos. So that becomes sine theta over cos theta divided by sine squared theta minus sine theta over cos theta. Correct. All I've done is I've just changed tan theta to sine over cos. Tick, I've got some marks already because that's what the recipe says to do. Then what do I do next? Well now, okay, I can't factorize this. Okay, and we don't, but you can see sines, cos, fractions. Okay, fractions. We are dividing. Let's recap. What have we got here? Sine theta over cos theta, that's the top, divided by, okay, sine squared theta, right? Divided by sine squared of theta. So what do? I say sine theta over cos theta times 1 over sine squared theta, don't I? All right? Remember that? This here is a critical thing in these equations. You're going to use it over and over and over and over again, especially when we come to the reduction formula, which is the next piece. Okay, let's have a look. Where's that leave us now? Just scroll up a little bit here. So now I say, right, therefore, this is going to be, I've done it on the side, so I'll cancel, leave sine theta. So that's going to be sine theta over cos theta times 1 over sine squared theta, okay, minus sine theta over cos theta, okay? Oops. And then what am I going to do? I'm going to cancel there, and we're going to have at the end of the day 1 over, because that's gone, leaving us with a sine theta there. 1 over cos theta times sine theta minus sine theta over cos theta. In these identities, right, what do we do here? Okay, when we see over there a plus or minus, we do it. In other words, add them or subtract them. That's what we do, because it's telling us to simplify. And remember, in algebra, what did we do? When we had those horrible denominator fractions, we put them all over the what? The LCD. LCD is going to be equal to, what do we do? Rule, cos theta, sine theta. What was my recipe before? Guys, it was take this and put it down. Okay? Draw a long line. Put that underneath, go to the next one and say, have I got a cos theta? Got it, I don't need that cos theta. Take it, then put the 1 down, the thing from the top. Remember this? This was the recipe for doing these. Put it down there. Cos theta, sine theta goes into there, leaving me with the 1. Cos theta goes in there, cancels the cos, leaves us with sine theta times sine theta, which is 1 minus cos squared theta over cos theta sine theta. And 1 minus cos squared theta is, sine squared theta over cos theta sine theta. And, well, here we can say, we can do some cancelling. That leaves us with a sine theta over cos theta, doesn't it? Oh, sorry. Sine squared cos over leaves us with a cos. It's 1 minus sine squared. Kevin. Okay. Sorry, my bad, guys. My apologies. I'm just really trying to go too fast. 1 minus sine squared. Kevin. But you see how it happens, hey? 1 minus sine squared gives me cos squared theta there. And then the cos is going to do the cancelling out. Oops, sorry, green. The cos does the cancelling out, leaves me with cos theta over sine theta. All right? So we say that is cos theta over sine theta, which is not cot theta. 1 over, and there he goes and writes cot, hey? 1 over, hey, tan theta. All right? You see how it makes. I make them as well. So that's we all do. Okay? So what did we do there? We just followed the recipe again. Here's another example, okay? This one I'm using because a specific reason that you'll see now. Okay? Example. And here it says cos to the 4th theta. No, this one I used x. Okay? Cos to the 4th x minus sine to the 4th x. Okay? Over cos x minus sine x. Sine x and 1 plus tan x underneath. Prove that that is equal to cos of x. Okay? Righty-ho. Okay, step 1, we say, right, left-hand side. And you must tell them what you're doing. You can't just write something down. Go through a structured process. Say, right, I'm going to deal with the left-hand side first. 90% of the cases is left-hand side only will give you the right. Very few do you see that you need to use the right-hand side as well. Left-hand side, okay. Well, I'm not going to rewrite it, obviously, because of time. Now, I say, right, I've got a tan at the bottom, and I can factorize. Common factor on top? No, there's no common factor. And what is in front here is a 1 and a 1, isn't it? Okay. It says no common factor. Difference? Yep. Difference of 2 squares. Do you remember we actually did an example, x to the 4th minus y to the 4th? That is x squared minus y squared, x squared plus y squared. Remember? So therefore we can break this down into cos squared x minus sine squared x. Okay? and cos squared x plus sine squared of x. All right, like so. Okay. And, yep, at the bottom, I say that is going to be cos x minus sine x over 1 plus sine x over cos x. Right. Now, this is where everybody, not everybody, but this is where it can go a little bit higgledy-piggledy, okay? Why? Because there's a heck of a lot of stuff to do, all right? First of all, I just recommend that I erase this. Okay. Can you see that we've got stuff on top? And once again, we can factorize. So keep factorizing, right? Keep factorizing. Until you can't. Keep factorizing until you cannot factorize any further. It's as simple as that. Now, if we're going to do that, we do this. We say, okay, let's go again. This is difference of two squares. Cos x minus sine x over cos x plus sine x multiply. What about that? Cos squared x plus sine squared x. And before we go any further, cos squared x is cos x times cos x, isn't it? Remember that. It's the 1 times itself. It's the shorthand way of writing that. Okay? It's like, but it's not the x squared. It's actually cos x all squared, or we write the 2 over there. Okay? Times, and no, we can't because it's positive. We cannot factorize the sum of two squares, so we have to leave it cos squared x plus sine squared of x. Put an x over there. And what do I do at the bottom? I say that is cos x minus sine x, okay, multiplied by, and this I must add together. You could go to the side over here and you could do your working over there if you wanted to, all right? There's no reason why you can't do that, okay? So cos x goes in there, okay, 1 goes, this leaves you with cos x, okay, over there, and plus sine x. Okay, how did I get that? This is 1 over 1 goes in there because remember it's 1 times cos x. Remember you bring that down. I'm not going to, this is a very simple one. Cos x and leaves me with a cos x, and basically cos x goes in there leaving me with sine x, right? And we've got all this lot. Can you see now straight away you've got a cos x minus sine x that can factorize, or sorry, that can multiply and cancel out essentially, right? Let me go back to black. So we've got that mess over there. Now, let's just have a look at that. Let's just write that down, shall we? We've got cos x plus sine x over cos squared x plus sine squared x, cos squared x plus sine squared. That should jog a memory somewhere. Hang on, let's just think. Let's just put a little, why is that ringing a bell in my mind? Hopefully it's ringing a bell in yours. It's an identity, yes, and it's equal to 1. Over, and at the bottom, we've got cos x and cos x plus sine x. Can you notice I am not doing half a dozen steps at the same time here? Okay. What am I doing? I'm doing it step by step. Why? Because these things are messy. So I do it step by step by step. I make less mistakes. We all make mistakes. But I'm trying to reduce the margin for error here. Let's do it one step at a time. Because I don't know about you, but I don't like trying to do 10 things at a time. Then that becomes, now we can say that's cos x plus sine x, because this equals 1, all times 1 if you like, right? and that is going to be over 1 divided, so I must multiply that by cos x over cos x plus sine x, right? And look what happens again. Da-da, gone. And we are left with cos x as the final answer, equals cos x. Now to complete it off, you would say equal to the right-hand side, therefore, da-da-da equals da-da-da, okay? Or cos x equals right-hand side, therefore proved, right? So, yes, they are, and I can't tell you enough, they're messy. I agree. Okay. Let's have a look at this. They say prove that. Example. Prove that the square root, this is quite a toughie, the square root of 1 minus cos x over 1 plus cos x is equal to sine x over 1 plus cos x. Right. Okay. Left-hand side, let's start with this thingy. Left-hand side is there. Okay. What is the left-hand side? The left-hand side is this character here, which is the square root of 1 minus cos x over 1 plus cos x. Now, if I had one of those emoticons that sits looking at this, I would say highest common factor, no. Okay, there's no common factors in there. Difference of two squares, no. Quadratic, no. Grouping, no. Therefore, I am left with conjugate as being my last option, isn't it? So I could then say, okie dokes, let's see. Let's do a conjugate. So inside there, you could, of course, use the right-hand side if you wish, okay? Because it looks cleaner, doesn't it? So let's do the conjugate. This is equal to the square root of 1 minus cos x over 1 plus cos x. And I multiply it by 1 minus cos x. 1 minus cos x. Why 1 minus? Because this here is the conjugate. Okay? I multiply it by the conjugate and multiply by the conjugate in the denominator. In other words, it's the same thing as rationalize the denominator. Remember that, everybody? Rationalize the denominator was way back in surds. So if you had 1 plus 2 root 3, you'd multiply by 1 minus 2 root 3. Okay? I am going to press on with this. We've got one more to do after this as well. Okay, so we say, right, I'm going to do that. So if you don't mind, I just want to change that to a half. 1 minus cos x is going to be equal to 1 minus cos x times 1 minus cos x. And at the bottom, I know that that is going to be equal to 1 minus cos squared x, all to the power of a half. Or you can keep your big surd sign in if you wish. Makes no difference. Now, moving along. That on top now gives me 1, okay, minus, okay, let's look. The top, that's 1 minus. Now, if I multiply it out, I get 1 minus 2 cos x plus cos squared x, right? Hang on, that didn't help me. It didn't help me, did it? No. Because why? Because that there, if I factorize this, I get 1 minus cos x. Sorry, right? 1 minus cos x times 1 minus cos x. This is a quadratic. It's a 1 minus, and what is that? That's 1 minus cos x squared, right? So what do I get? I get 1 minus cos x squared over 1 minus cos squared is sine squared x, all to the power of a half. Now I go back and I remember in my surds. I remember my surd equation, which said, over here, take the half in. Do you remember that? The half must go in both ways, top and bottom. Well, that leaves us with on top 1 minus cos x over sin x, okay, which is what we were asked to do. All right. Now, similarly, we could have said using the right-hand side. Okay, we could have said sin x over 1 plus cos x. Okay, then we'd multiply by, I'm using conjugate here again, right? I'm using the conjugate over here, multiplied by 1 minus cos x over 1 minus cos x. Can you see here, just to reiterate again, this is the conjugate of the denominator. Okay, so we always use the conjugate of the denominator to do that, because we want to put that into something that's going to be essentially the sum of two squares. So on top we're going to get sin x multiplied by 1 minus cos x. Bottom, I know that's going to be 1 minus cos squared x when I do my little working out. And let's just take this. So then I can say, okay, that is, hang on, 1 minus cos squared is sin x, isn't it? Okay, that's going to be sin squared x. Then I can cross cancel over here, leaving us with sin x at the bottom, and eventually we end up with exactly the same. 1 minus cos x over sine of x, which is equal to left-hand side. Therefore, we've done it. Now, with these proofs, we are doing simplification. All I can say to you is really just make sure you do a few cross sections of them from the book, right? And yes, they sometimes are. You're not going to see it. It's going to be a bit of a struggle, okay? But at the end of the day, the factorization, and I'm going to say it again and again, the factorization is key to actually this entire section on trigonometry, because we're going to go to trig equations next, where we're going to be asked to factorize and solve for. You can see that the same recipe is coming out again, isn't it? Simplify and then solve the equation. That's the process we're following. The difference here is you're proving an identity in the thingy. Oh, one last thing. Once you have proven the identity, you actually can use it in the next question, right? You don't have to restart it. So if we have proven this and they give us something, you can use it. They will often say, using the above, do something else, okay? Show that, for example, right? So we have proved that, okay? And we may use it. In the next section, I'm going to be doing reduction formula, okay? Where we're going to go through the 180 plus the various angles, and there's a whole load of minuses, and where I think there's 12 or 16 where some students try and memorize it. Don't. It really don't. To memorize like 16 different things, it's going to take you longer to go and find it in your memory than it is to apply a very simple process to actually find the answer that you're trying to memorize, okay? I'm a firm believer in, you know what, don't try and memorize too much, because I'm not going to clutter out something that I can actually work out myself. Okay, cheers. Have a great one. Please practice a few more of these. I'm going to add loads more in, but at the moment we don't have the time to do that, because we're trying to get everything sort of sorted for the syllabus. But we'll be back and do loads more of these. Cheers. Have a great one. Bye.